I built a 3-motor VIQRC legal Swerve drive, and today I'll be explaining how both the hardware and software work. For step-by-step instructions on how to build the Swerve drive for yourself, check out my other video, which is linked in the description down below. This Swerve drive uses one motor to pivot the angle at which the module is facing, then has two motors to turn the wheels to move the robot forward or backward. This allows the robot to move omnidirectionally while keeping its orientation in the same position. To pivot turn, where the robot stays in place and turns, both wheels rotate in opposite directions. For drag turns, where the robot turns around the wheel, one wheel stays stationary while the other rotates. And lastly, to arc turn, which is like how a car turns, the two wheels rotate in the same direction, but at different speeds. To pivot, the motor turns a 12-tooth gear, which then turns this 60-tooth gear, which turns the 60-tooth gear connected to the module. This results in a 5-to-1 gear ratio, which helps the pivoting of the module be more precise. To spin the wheels, these two motors on the top of the Swerve module each spin a 24-tooth gear lodged inside the module. These gears then spin their own respective 12-tooth gears at a 1-to-2 gear ratio for more speed. Moving the motion along the shaft, the motion is transferred to these bevel gears, which then turn the wheels. At first glance, this robot may seem to have a lot of unnecessary things, like why are there flywheel weights on the back? These weights are actually to balance out the weight of their brain on the other side. Without the weights, the robot's movements would be unbalanced, as the center of mass is skewed off to one side. With the weights, the center of mass is moved back towards the center, allowing the robot to move as intended. These gears on the side may also seem useless, because they aren't powered or power anything, but they are actually here to keep the Swerve module stable. Without the extra gears, the Swerve module would just fall out of its frame. These omni wheels on the sides also have an important role to play, as they keep the robot balanced, as the bot can't balance on only two wheels. On the software side, the first thing we need to do is determine if the driver wants to move the robot or turn it. In my code, the left joystick is for turning and the right joystick is for moving. By checking whether the left joystick is being moved or not, we can determine which set of functions the robot should follow. If the robot is being told to move, we first need to find out what angle the robot is being told to move towards, and we find this angle with some trigonometric equations to convert the axis C and axis D positions of the joystick to a set angle for the module to turn towards. There are also lots of conditionals in the code to ensure the set angle or whatever variable has a value that makes sense for its application or makes sense to the robot, like you see here. We then use a P controller to have the module precisely stop at the set angle by making the speed the module pivots at proportional to the amount of degrees left to turn. So the closer and closer the module is to where it's supposed to be, the slower and slower it turns, allowing it to come to a slow stop when it reaches its destination, preventing the module from overturning and ending up at an incorrect position. To determine the velocity the wheels spin at, we set the velocity of the wheels to the distance the joystick is from its rest position. We find this distance by using the Pythagorean theorem. For turning, we can use the same turning logic as a standard tank drive. We set the left wheel's velocity to the axis B position added to the axis A position, and the right wheel's velocity to the axis B position subtracted from the axis A position. This way, by moving the joystick directly to the left or right, we pivot turn. We drag turn by angling the joystick to any position where the joystick is at a 45-degree angle from the axis, and everything in between is an arc turn. If you want to check out the code for yourself, I have it in the description down below. So that sums up my explanation of the 3-motor Swerve drive. I hope you guys found the Swerve drive series interesting or educational, and if any of you end up using this drive chain in a competition, let me know. Thanks for watching, and I'll see you in the next video.